While inspecting the exterior of any building, it's very important to have a routine. If you're inspecting to the COMSOP, the exterior is absolutely part of your inspection. One of the things you need to look at is the drainage. Beyond that, when we watch how water flows around the building, then you'll create your flow, because really it has to start with water and how water flows in, around, and away from the building. Then beyond that, we're going to talk about, as we go through the exterior of this inspection, the building, the drainage, the landscaping, the lighting, some of the hardscapes, some of the softscapes, and as well as anything else that we find. So with that, let's get started on our exterior inspection. In looking at the exterior of any inspection, the real key is how does water flow? Water can have a tremendous influence on any building. And so as water flows, we do not want to have it flow into a building. We don't want to have it pond. There's been great instances of parking areas flooding. You might not think they flood, but if just a little water pools around the drainage spots, I've actually seen it where it floods cars during rains. And so there you are, you're in a facility like a grocery store getting your groceries, and you come out and your car's flooded because they got a ½ inch of rain. So as an inspector, inspecting to the COMSOP, we want to look at the topography. How does drainage flow? In this particular property, as you see over my shoulder, the parking area is drastically higher than me. And then it's flowing past my feet. And so the key is to watch that flow. And you really want to watch, as you're doing this, everything that's around us. That could include adjacent buildings, that could include adjacent properties. And so in this particular instance, it's very visual, the pronounced excellent drainage they have. If it's a little bit more subtle, I have found a golf ball to be my friend. And I could put a golf ball in one section of a parking area and watch it as it moves through. The particular parking area that we have here is asphalt. Very specifically, it is a surface mix. And when you look at that, that's when you can tell it's a surface mix by how tight the stones are with the sand. If it was a different type of mix, it'd be a little bit more coarse. And so we want to look at that. And so as we go through our inspection, I'm watching the drainage, and we're going to see where it ends up. Hopefully, as it ends up in our drainage, it's going to end up in something that's not going to pool, pond. It's going to end up, if it catches it, discharging it somewhere else. The standards say we do not have to inspect the interior of a catch basin, but we do need to watch the drainage. And so I'm not really concerned, as far as my inspection goes, of where the catch basins distribute the water, as much as, is there a catch basin and will it catch the water? So with that, let's go look at a catch basin. So as the water migrates down this parking lot and all this overland stormwater is cascading through here, it's going to assemble over here where we created this inlet area in the curbing. And so because of that, they've installed this very large catch basin drain to capture this stormwater. And it moves in a couple different manners. We've got a drain that comes off this way to a catch basin that's upstream. And then we've got another discharge here, and then we can see where it's discharging out. Again, in our standard, we don't have to pop the lid. We're not opening this up. All we're doing is trying to verify where this water is coming down the hill and will it be captured. The other thing to look at, there's a couple of different types of catch basins that we have. This one is in a parking spot, so it must be strong enough to support the weight of a vehicle conceptually. And if it was out in the landscape area, maybe it doesn't have to be so robust. But what we have to be concerned with on all catch basins is the structure of it. Again, we're not popping the lid, but there are some signs that will tell us if we've got structural breakage. One of the signs would be, if we look at the catch basin, this particular catch basin does have a very nice concrete structure about it. But one of the things that can happen is the underground portion is installed by an underground company. And then a lot of times the very top is set by the company that does the parking lot. And so when the underground company leaves the drain, they leave it low. with the idea can be adjusted for the perfect height of the end of the asphalt, because they don't know a month or two in advance where the asphalt or the concrete or whatever the surface of this parking lot's going to be. And one of the challenges that can happen is when they make that adjustment, there could be gaps, and in those gaps it becomes an erosion point. So if we keep driving on that erosion point, we can tend to create a divot, a hole, a sinkhole, a collapse point, a structural point that needs to be identified. And so as you're doing an inspection, if you look around the grate, if you look around the lid of a catch basin, and you start to see it's bowed in or divoted, that's usually a structural integrity loss that you would absolutely want to note on your report. So that's always a little tip and something you should watch for your clients. There are all kinds of methods for inspecting the topography. Some people like to stand at the top. Some people like to stand at the bottom. I particularly like to stand at the lowest point of a property, and so that my eye can see everything. In this particular property, this is the lowest spot of the drainage. Everything's flowing this way, everything's flowing this way, and as a consequence, I've got all this debris around this drain. So, not saying that it's something we're going to talk about with the maintenance, but this would be one of those things that if you're looking to add some consulting value to your inspection, you can certainly recommend to your clients they keep this well clear of all debris so that we don't pool, pond, flood. That can mean a lot of different things. If you have a building in a climate that freezes, if this is all flooded and freezes, it's going to be difficult for vehicles to make this turn, and without cascading into the concrete or something else. Where the other catch basin that we looked at previously was structural with the concrete around it, this particular one is surface to the asphalt. And so again, I will be watching to make sure I don't have any drainage issues that are happening right in this area here. So that's very important. Again, watch the topography. Our standards say we need to watch the storm drainage. Where does it go? If we didn't have these curbs, which some properties don't have curbs, then maybe there's overland drainage, and so we want to watch it as it cascades that way. So it's very important, watch the water. In the perfect world, your building sits highest on the property and the drainage goes around it. When we have any property that's got tremendous amount of relief in the topography, in order to level it off, the best way to do that is through the use of retaining walls. There are a lot of different products that can be used in retaining walls, ranging from timber to poured-in-place concrete to these, which are a filled stone. What we can't see in this particular retaining wall is whether or not there's any deadmen or tiebacks going back up into the wall. But what we can see is this particular wall is stacked, and it's stacked in a format where it's leaning inward, not outward. The key is we want it inward so that it doesn't topple forward. And so as you're doing your inspection of the retaining wall, the key is it plumb, is it level, is it square, and is it straight? And so I'm watching these lines for straightness, right? And levelness. If all of a sudden it's dipping up and dipping down, then that would tell us we've got some movement. Then on top of that, I want to make sure that it's uniform. It doesn't have one of these courses that's set in much farther than a different course would be. And so we want to watch for that. And then on top of it, when you look at the top of the retaining wall, you want to make sure the vegetation is level. If all of a sudden behind this retaining wall, I've got a big divot, a dip, and maybe that dip could have been put in there if it's uniform the whole length as a swale, but most of the time they're not. Most of the time they're a level surface back there, and what we don't want is a dip, because the dip would be a sloughing, they call it, or a settlement in the soil, and that erosion is coming out from somewhere. So again, as we look at retaining walls, have they moved? Is the move active? Are they level? Those are the key takeaways as you're looking at these retaining walls. But it's very important that you do look at retaining walls during your exterior inspection. Throughout the exterior of a property will be lighting. Lighting does a couple different things. One, it could be building security. So some buildings might have building particular lighting, either up lighting or down lighting, but a lot of the lighting installed on a property is for employee or guest or patron or whatever word you want to use, security and safety. And so in this particular case, we have a concrete base with a steel pole that goes up into an LED light. As part of the exterior inspection, you should try to go inside, find the light timer so you can illuminate these lights. We'll do that a little later on in this session. But what we want to look at when we look at these lights is we want to look at the base. In this particular base, they went with placing the lighting inside of this peninsula or island. By doing that, it's protected from vehicle impact. It's behind the curb and it's inset in here. They've elected to install this lighting inside of a canister. This is a corrugated tube, and then they've left the concrete in there. There's typically underneath this shroud 4 or 5 anchor bolts. Those anchor bolts go into the concrete, and then the post goes up. According to the National Electric Code, the two things that are supposed to be present on these posts is it's supposed to be free of rust and graffiti. And so as I look at this pole, it's certainly free of graffiti and it looks excellent. What we have great fear of is as these steel posts wear, this one has a very good coating on it. Some of the other coatings can start to fail. And as they fail, these rust. And lights typically are overlooked from building maintenance. And so if this was to rust, I think what we're going to have in the next decade or so, a lot of light failures happen where they're going to start coming down. Now, as the lights go up, we have to have a handhold or a junction box. That's right here. This is where the wire connections that go up to the light fixture and down into the base that eventually go to the connections wherever they're located. And so it's very important to note that cover is in place. These lights can be either low voltage or high voltage. They can be 120 volts, or some of these lights can actually be 277 volts. And so if that comes in contact with somebody for no other reason, but hey, this looks like fun, I think I'll put my hand in there, then they could be electrocuted. And so we want to make sure the cover's on there. So as we go around the property, you want to make sure that there is outside lighting for the parking area, whether it's from a pole or from a building coming down, and is it in good shape? And then lastly, can it be impacted by cars? During the lighting inspection, it's very important to verify that it operates. There's usually a timer located in the building. The timer is basically an hour timer, what time of day you want it on, what time of day you want it off. And some facilities have photo sensors, so it's a dusk to dawn type situation, especially if we have a spot where a storm might come in the middle of the afternoon where the timer might not work. The photo sensor would supersede the timer. In this particular case, we found the photo sensor and we've put a piece of tape over it to make sure it looks like it's dark, and then that's what's illuminated our lights. While inspecting the exterior lighting, it's very important to find the controller for it. Some controllers are timer operated, some controllers are photosensitive or photo operated. This particular one is photo operated. And it's outside here through its own meter socket because all of the lighting in this property is controlled through here and separately metered. Not all buildings are separately metered. Sometimes we'll find these in the control room for the electric, sometimes when they're in closets, and in this case, because it's controlling this entire complex, it's out here. So it's important to note where it's at, and again, you want to look at the electric safety. Is the electric contained? Is it tight? Or is there any openings or anything dangerous about it? So that's what we want to look for. Beyond that, it's just a matter of operating the exterior lighting. There are two more interesting elements to the exterior portion of the inspection that is not found on a residential inspection. That's landscaping and vegetation. They're two different things, which is kind of odd for us to think about. And so when we want to look at it, to really not be so in depth, if it's green, is it green? Does it look well maintained? Is it overgrown? When I think about vegetation versus landscaping, I think of trees. I think of trees growing up over a building. Does the tree influence the siding? Does the tree going to drop debris, leaves, or even scuff the roof? And so in this particular property, all of our vegetation is pretty new, pretty young, so it doesn't really have much confluence on the building or influence on the building, but it's something to watch for. As I look at this particular architect and landscape designer has gone with a rock finish, so we don't have mulch that's degrading. And then we've gone with some simple vegetation through here, some forsythia and some spirea. Not saying that you have to know what those are because that goes well beyond us. But it's just good to know that does the landscaping look intact, alive, and maintained. I think a good comment would be if you saw something that was not well maintained, just let your client know that the landscaping is not well maintained. A lot of times you're going to have a client that maybe they've not seen the building. Maybe they've only seen pictures of it and they're off-site or off-country as they purchase the building. And so our job in following the CompSop is to identify landscaping as well as vegetation, and so that's what we're doing here. And we'll do that around the entire property. But on this particular property, it all looks very similar to what we have. Again, a rock finish with landscaping and vegetation placed in it. The parking area could be constructed from several different products. This particular one is asphalt. With asphalt or bituminous asphalt, it's sand, it's aggregate, and it's the asphalt emulsion that is typically heated about 350 degrees and then laid or placed on top of a suitable bed. So as we're looking at the asphalt, there's a bunch of different types. This particular type that we have here is a tight sand and small gravel mix. Most asphalt companies will call this a surface mix because it can be compacted and smooth to as smooth a surface as we could get. Little wider gravel, little larger aggregate would be a base mix or a binder mix that they'll place on, because this could have several different layers depending on how thick they want the mat. As we're inspecting this is a relatively new parking area, so it's not going to show us the pronounced defects an older parking area will have. With asphalt, the condition of the asphalt needs to be periodically rejuvenated. And what that is that's usually a seal coat. It's usually the same asphalt material that was embedded in the aggregate and heated. It's the same material and it's placed on cold, and it's usually laid on almost like painting. And so when they do that, the idea is as the UV comes down and breaks down the asphalt, it starts to degrade that bituminous mix. And by adding the sealant, then it binds it together and hopefully prevents a lot of the cracking from happening. And so when you look at an asphalt parking area, it's not necessarily a bad thing to have it been sealed. If a parking area's design life is 20 to 30 years, maybe it needs to be sealed 3 or 4 times during that life. And so as you reseal, then that's when they'll usually restripe. And so one of the things we're going to look at as we go through is what is the condition of the asphalt? Is it pitting? Is it cracking? Is there trip hazards? Are there spots like potholes? Potholes would happen if the mix is not either right, or if we've got heavy traffic, or maybe we don't want to use the nasty word of a snowplow, but maybe a snowplow's broken it up. And so we want to watch for things like that. And then as it wears and the UV breaks down the asphalt, it can start wearing out the painting on our striping. We'll talk about striping in a moment, but as we look at this, one of the things to be concerned with as we look up the hill is, has constant vehicle traffic created a memory or a rut? And that can even be found in new asphalt if the base wasn't created right. And I think it's going to be important during the inspection and the paving and parking area inspection to note if there's areas of wheel ruts, cracking, potholes, trip hazards. So we're looking at the difference between surface material and binder material or base material. This will have smaller aggregate, 3/8 inch or less rock, and then this rock could be as big as 3/4 of an inch. This will have more sand and more bituminous material. This will have less sand and the same amount of bituminous material. And what this does, is this adds the strong base, and this adds the smooth finish. And by doing the combination of these, this allows us a very strong, long-lasting parking area, or in this case, thoroughfare driving area. If you imagine, you could have a wide variety of weight of vehicles. And so by doing this combination, we're pretty much doing the best we can to make this as strong and as thick as matte as we can. During your paving portion of your inspection, it's very important to keep everything in perspective and keep your eye, basically on the entire picture. So part of the paving inspection, you have to think of accessibility, and you have to think of how are the people that come to this building going to know where to park. Is this an open gravel parking lot and it's parking willy-nilly, or is there delineation? In this particular parking lot, we've got really excellent delineation for each of the parking stalls. And so as you're doing your inspection, you should make sure that the parking stalls look uniform. It's a visual clue. I'm not saying we need to go out and measure every one to make sure they're 8 foot or 10 foot or 12 foot wide, but you should just make sure that they're clearly marked and that they're typically uniform. And then on top of that, with accessibility, if you're going to do a full accessibility inspection, then there's certain numbers that you need to be concerned with the number of accessible parking spaces in proportion to the number of regular spaces. But in our case, what we're looking for, since we're not doing an accessibility inspection, is, are there accessible parking spaces? There's one here, 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 and there. And is there one with van access? That's what this one is, and that's what that one is. And then beyond that, if they're in the parking lot, can they get to the building? And by getting to the building, that's why we have the curb cuts and the accessibility ramps installed, because that's really the key. We've done a lot of buildings that they'll have wonderful striping, and then the people that come to the building can't get out of the parking lot because there are no cuts. Now, if they're cuts, are they smooth ramp cuts, or is there some form of depression, cracking? These particular cuts that we have in this building, if you see the dimpled, that's specifically for visually impaired, so that they can use their canes and find the dimples and note that that is a depression and a curb cut for which they can get into the building. So again, on our accessibility inspection and our quote-unquote parking inspection, we want to make sure our striping is in good shape, uniform in width, as well as is there accessible parking areas. On the exterior of any inspection, there's typically concrete. For sidewalks, I shouldn't say typically, but many times there's sidewalks. Sidewalks are largely made out of concrete. Concrete is a mixture of small aggregate, large aggregate, Portland cement, and enough water to bind it together. It's almost like making pancake batter. The whole idea is we want to make it in such a thickness that it's able to be poured in place, held up, and then cure. It's typically striked off to the level surface that they need. In some cases, it's broom finish, sometimes it's smooth finish, and then it's allowed time to cure. Concrete requires 28 days to cure to its technically designed hardness. Well, albeit some concrete never cures. If you think of the Hoover Dam, there's concrete in the middle of the Hoover Dam that is still as wet today as it was in the day that it was placed there 50, 60 years ago. So with the concrete, it's what we call exothermic, which means it creates its own heat. When it creates its own heat, it begins to crack. Most of that cracking happens in that first 28 days. And so to prevent cracking, sometimes we'll put joints in. In this particular case, we put cut joints, where while it was still very fresh, usually within the first day or 3 of it being here, they came in and they cut the concrete. So what they're called is control joints or expansion joints. Typically, we call them control joints because we're going to control or suggest where the cracking happens. Sometimes we'll also make an expansion joint, which is using a felt type material, and in that case, we'll use this felt type material to allow this large mass of concrete to have some place to compress and expand into. So as we're looking at the concrete, we want to look for cracking first of all. Is there cracking as we go up and down the plane? And if there's cracking, are they large enough to be a trip hazard? Typically, we call anything that's more than a 1/2 inch of a rise a trip hazard. If you think of somebody that might have mobility issues that can't lift their feet fully, a 1/2 inch is enough to grab their shoe and allow them the opportunity to trip and fall on the concrete. Then the next one of the more other important things we want to look at when we're thinking about concrete is at front doors. Does the door pass over the concrete perfectly, or is it rubbing? You'll see a lot of strip malls and a lot of inspections on exterior buildings where the concrete is raised or heaved upward and the door becomes obstructed. And so sometimes we have to come in and mill that concrete down to allow the door to swing. Because we know during the inspection of a building, all doors have to swing outward so that we can exit the building safely and not open inward. And so again, we want to make sure it swings perfectly above the concrete. And then we want, again, look for cracking, look for the joints, and then we want to make sure that you look at all the concrete as we're going through the building. So I want to do my inspection. I'm going to carry forward through all the concrete. This particular property is unique as far as it's got tremendous amount of topographical relief. Where we got our concrete that comes down this way, we've had to transition to this lower area where it's too tight to make it a ramp. And we'd lose too much property in here, so they've elected to make it in stairs. Again, for accessibility, we have an area up there that is perfectly fit and perfectly fine for the accessibility. If we would have placed accessibility parking down here, which would have been very bad, we would have had to make a ramp here so that somebody can get into the building or out of the building back into the parking lot. But in this case, we've added these steps. Again, looking at steps, it's the same standards that you're aware of. We have to have consistent height in our treads, our risers, consistent width in our treads. We need to make sure that no riser is more than a 1/2 inch or a 1/4 inch off of the next one. But then on top of that, we've got this steel railing. Steel rusts, so if it's not well coated, it will rust. We're starting to rust here where we've had some impact. It's very possible we could have been piling snow here during snowplow times. Looks like we've had some impact in here, and so we want to watch for the general rusting of that. But then on top of that, where we typically get our failures, and we're starting to get a little crack in here, when we place the concrete here and pour it, we'll typically add a spot in the forming so that we can accept the anchors for these 5 posts. And in doing that, that's a weak spot in the concrete. And so water can pool in here, freeze, thaw, seep, begin to rust out these posts. And so we want to watch to make sure we don't have any cracking as it comes up and down those anchor points. So it's very important to look at these because they have to be solid. As you're going up and down these stairs, you're relying on the structural integrity of these posts to hold you up and to serve you well. And so we want to watch for that and make sure there's a railing. Whenever stairs are wider than 4 foot, we have to have a railing on both sides. Every building requires 2 means of exit. In this particular building, it's set up where we've got office space and then there was a warehouse space. And so if somebody was in the office space, this back door becomes their secondary means of exit. With the front door we've already looked at, we have the swing, we have the accessibility section of that, very nicely identified. But on this back, if they were to come out this door, we are almost 3.5 foot higher than the parking lot. So if somebody needed to have an accessible exit, they had to create this ramp. And so this ramp is put in, and the same railings that are on the other side of the building are here. They're anchored into the concrete. So as you look at this, are the railings free of rust? Are they solid? Are they graspable? Is there any spot on the maneuver of this railing? Because we have a guardrail here and a handrail here. The guardrail is too wide for the standards for a handrail. So we have this is 1.25 inches here, and we have this which is almost 1.5 inches here. So we need to have something that's graspable here. And so on that, can my hand maneuver the whole way? Or is there something here that's going to catch it and we call that a pinch point. So we're going to watch for pinch points as we migrate through here. Because we've got this large mass of concrete, there's always a fear that this mass of concrete, as it expands and contracts, is it going to influence on the building? So that's why we have an expansion joint with expansion joint material placed between the concrete and the foundation. So we want to make sure, again, is this free of cracking? Are the railings free of rust? Are they solid and are they secured? And then the other thing would be to monitor the ramp to make sure the slope is not too great. During the exterior portion of the inspection in the ComSop, the inspectors should inspect the siding. In inspecting the siding, we should note the type of material. This particular building, we're going to have several materials we're going to inspect and have to talk about the relative defects that are present with them. First, we're going to have this corrugated steel siding. With the corrugated steel siding, it is installed using gasketed fasteners. Those fasteners are self-tapping. They go in through the steel into whatever substrate we have on the building, and that's what attaches the steel siding to the building. In looking at that, we want to make sure the same general principles involved in all types of inspections adhere to this product, which is ground contact. In this particular case, the siding comes down and it is embedded in this landscaping and in this topography that's over here. So this would be something that I want to do two things for in my inspection. One, note the presence of this ground contact here, and two, when I go on the interior of the building, does that ground contact add moisture into the building? So those are two things I want to be definitely aware of as I walk through the interior of the building, and so I will have to take a note of that for myself, whether it's a mental note or a note on whatever note-taking device I'm going to use. And then on this case, we're going to migrate, we'll walk through the rest of the exterior. We do have building lighting. These are installed surface mount lighting. There's one on top of every door and every unit. This particular lighting does have a photocell, so it is attached to a main power control, but there's a photocell, that's the gray element that's next to it. That actually supersedes or will turn that light on when it gets dark. We've got double doors. These are a steel door. The steel doors are typical on most commercial buildings because of security. We don't need to put a wood door on, for aesthetics. We want a steel door for security. As we look at the steel door, you want to make sure that the frame looks good around the three sides of the frame. We want to make sure the door panels look good. We'll exercise these doors as we go inside. This door is locked, which most doors are. One of the most common defects we're going to find on a steel door would be rust. Rust on the frame on either side, or rust on the bottom of the door slab. Typically that rust is from the heat of the interior of the building. We might not have a sufficient or a proper amount of weather stripping, and so the heat of the building wants to roll out from under the door, and it typically rusts the bottoms of these panels. So I will want to watch for that. I know we have a nice aluminum kick plate on the bottom of this door, but I want to watch for that. We do have outlets as you go through the exterior of the building. Through the standard, it is our responsibility to test the GFCIs, make sure they operate, and then we want to note any defects that might happen with those. And then we have this overhead door. This is a rolling overhead door versus a sectional overhead door. On a rolling overhead door, there's a coil up on the top which operates the door, and then the door just moves up and down the track. We want to make sure it's sealed across the bottom, make sure it's flush and hasn't moved, or the concrete hasn't moved, and we want to make sure it's free of rust damage. This damage could be surface damage from impact, or it could be from dropping it, and you'll see some dents, could be anything. And then we just want to migrate through the siding, looking at, is it bulged, is it damaged? One of the things that can happen to steel siding as it ages, this building is really, really new, but as it ages, it can start to chalk. That chalking is the surface material starting to break down. And as it breaks down, then that chalking can start staining things, make the building look aesthetically drab and less attractive. And if that's the case, we probably don't want to power wash it, because you'll take all that chalking off and be left with bare siding. And if that's the case, I know steel is very likely to be having to have a paint coating eventually. When we talk about the gaskets and we talk about these connectors, this is the failure point on any metal building, and any metal roof for that matter, is where that gasket is. And so sometimes the self-sealing, whether it's a vinyl or a rubber material, that's what wears out. So that's something we want to watch for. And then we'll just walk the rest of the building as we head this way. In the construction of a building with masonry, there are two types of masonry we'll have. One is veneer and one is structural. Veneer meaning it is not the structural element of the building. There is some substrate behind that holds up the building, whether it's a steel frame, a wood frame, or even more masonry behind this brick. In this particular brick, this is veneer brick. Very specifically, it's face brick. See how pretty it is? It's not a common brick, which is a little bit more tumbled, a little bit of an older styled brick. So when we have this face brick that's on here, it has to be held by something. That could be a brick ledge, where the concrete on the foundation is actually wide enough to support the brick. Or in this case, we're here, it's being held up by this lintel. That lintel that's there is actually supporting the masonry that's above it, up until the point that the concrete can support it. When we have veneer brick, it's very important that any water that's trapped between the brick and the substrate has the opportunity to escape. And as it escapes, it comes out through areas called weep holes. Weep holes are set up so that if any water goes between the masonry and the substrate, it can travel down the wall and exit out. In this particular case, we filled these openings with a fiber, and then that fiber doesn't allow direct access to rodents into that area, but it also allows water to come out. As we look at this, we're going to have those weep holes across the bottom at some regular interval. I've seen it as much as every brick. I've seen it as little as every 10 bricks. There's not really a set standard. It really depends on how much hydration we get to a building. But in this particular case, it appears to be every 4 bricks, we've got a weep hole. The windows on a building are non-structural. Windows are typically, there's a bunch of different types of windows. We can have a curtain wall situation where the windows are supported and hung like a curtain on a building, or we could have what we describe as is a paneled window situation. This is a paneled window situation where the panel of windows is placed between the structural floors. And so having those windows between the structural floors, again, this window assembly and this glass is not a structural wall, even though it's a thermal wall in between the interior of the building and the exterior of the building. When we add the window in the brick structure, we have to have an item called a lintel. A lintel is the piece of steel that goes from the brick to the brick, the width of the window. We typically want to do it at least 1 brick wider. And in this particular case, I've got a lintel that's 2.5 bricks wider than this, so that that steel holds all the masonry that's above us. And that way the masonry weight doesn't collapse and crack and damage the windows. In placing that lintel on the building, holding the brick, protecting the window, we have to have the same weep hole situation. Because if I've got a weep hole here and here and here, and it's doing this great job dewatering here, what happens when I have this 12-foot wide window pane? If I don't dewater it, water will get trapped at the lintel. So in this particular building, we've got this excellent wicking system from the weep holes that's going on above the lintel. If moisture gets trapped in masonry and doesn't get out and has a chance to, through a capillary effect, go from the interior to the exterior, that's typically resultant in something called efflorescence. Efflorescence is salt. Efflorescence is the remnants of moisture. Above this window here and below the window above us, we do have a section of this wall with some efflorescence. We do have a little bit of section of efflorescence below here. So there is some history of moisture that's gotten in behind the masonry that might have not come out. And sometimes in a newer building like this, it's left over from construction too. So you don't necessarily have to say it's a bad thing, but just noting the presence of efflorescence is probably enough as a comment in your report during your exterior inspection of the masonry. So again, in looking at the masonry, we want to make sure it's straight up and down the wall. There are weep holes if it's veneer. Is it supported, which is this lintel here, or the concrete? And is it structurally sound above the windows? I don't want to say structurally sound as much as, are there lintels, and are they not sagged, and are they not rusted? As we continue around the exterior of this building, we first come across this expansion joint that they've placed right here. And this expansion joint is because we've gone from a lower area to a higher area, and it's a good spot where the wall will be more subject to cracking, especially as the water migrates down the metal siding and hits the top of the masonry. In that spot, we've actually added a beautiful drip cap. That drip cap, as you can see, rolls over the masonry a nice solid inch and a half, the entire width or length of this wall. And because of that, all that water that cascades down the metal will have a chance to flume over or sluice over the top of the masonry and not travel down the masonry. But as you can see, right up here in this area, I have a little bit of efflorescence growing. That efflorescence is probably from any of that water that's perfectly not being controlled at this one flashing joint. And so it would probably recommend for a little bit of extra sealant being placed there, because there is probably a small gap. As we walk around the window surface here, I've got this beautiful window. It's an aluminum frame. We've got a double pane glass. That glass is inset in here. And on these windows, there's always a gasket seal. That gasket seal can open in time, and so we want to make sure that you watch these spots on all these lights. On this particular one, we've got 6 lights or panes of glass, and so any one of these can start to shrink. If water comes down and cascades down this glass, it wants to project itself into that gap. And so watching that gap and that seal, a lot of people call that a storefront seal, because you imagine windows like this in the storefront of a building. And so that little gasket is typically a rubber material or a vinyl material, and as the UV breaks that down, it tends to want to shrink. But there is a mastic, almost comes out of a gun, that you can place in there to seal that real well. And then just like any other surface, wherever there's a horizontal and a vertical surface, it should be well caulked and well sealed. And that's what you want to catch as you walk around the building. Again, we've got a lintel, we've got the weep holes. We want to make sure that those are in place as we move through the building. Being careful not to walk or stumble as you walk. Remember, the masonry does need to be well supported, and that is usually supported either, again, on a lintel or on a concrete or a brick plate in the concrete. And so that ledge is got to be there. In this particular wall, as we extend over here forward, the wall was constructed wider than the foundation. Like the lintel we had to have on the other side, we had to place this channel bracket here to support this storefront wall or window wall as we have here. And so it's really important that everything be supported. And so as you walk through this building, if you saw that they did not have that channel and the building protrudes out wider than the foundation, that'd be something for you to want to take interest in and take a good look at. In this particular case, by adding this bracket here, we're holding up this window assembly. And again, you're going to walk through and you're going to verify that we have good sealant on all of these panes of glass. Then beyond that, we have this material here, the synthetic stucco or EIFS, exterior finishing insulation system. And so on the EIFS, You can decide whether you are going to do an intrusive investigation or a thermal investigation of that. That's really up to you and your client's expectations and what you've agreed to, or whether you're just going to do a visual inspection. Most inspectors can do a visual inspection. You're looking for cracks, openings, seams, any form of physical visual damage. That's something every inspector can look for. Every inspector should know the basics of what synthetic stucco is. Whether we have an expansion joint at the floor lines to prevent any cracking, and whether or not we have openings in or around windows, doors, protrusions like lighting, switches, outlets, etc. Beyond that, if you do a different, more intrusive investigation, doing a full-on moisture test, then that would be up to you through agreement with your clients. One thing to talk about with EIFS that's completely different than residential. Commercial buildings don't have the same problems. Typically don't have the same problems because of the different types of construction. But they also don't have the same problems because, unlike residential, these don't have the same moisture problems. And so to immediately go, oh my, we've got EIFS on the building, like you would do for a residence, you don't necessarily have to do that with a commercial structure. So just know that we want to look for the basic elements, look for the physical damage. Then when you go inside, you can look for any interior moisture considerations. But then beyond that, that's really, for most commercial EIFS inspections, that's the most important stuff that you do. Continuing with the exterior of the building, we're at the front of the building now, and we have this portico, or this little overhang for the front, well, lack of a revenue, we'll call it front entrance or front porch. We have 2 steel columns, and on that we have a masonry base. The steel columns should hold it up, so when you're doing the inspections, you should make sure things are level and square and plumb. And if these are rusted, you want to make note of that. When we look at this, we want to also make sure that it's dewatering. We've got a little downspout over on this side, but we want to walk through and we want to look at the glass. We want to make sure, again, the door swing goes over the top, and so we have proper door swing, and then it always has to swing out. It should auto close so that it doesn't stay open. It shouldn't close so fast that it's going to hit somebody's heel as they're trying to walk in. So imagine as you want to see that as you go through. We've also got a GFCI in the front, just like we had the GFCI in the back. You want to test to make sure it trips and resets. As part of the electric standard, it says we should test GFCIs and make sure that outlets that require GFCIs have them. This is the exterior of the building, so therefore we have to assume that it's required, and we absolutely need that. Look at the glass. We want to look and make sure that, again, the seals are in good shape. I'm not talking about the thermal pane seal. That's the inert gas between the glass, as that is beyond our standard to identify those. But I am talking about whether or not this gasket is here. As we look through, we want to check every window for that gasket, make sure that's solid. Again, we're going to look at the steel siding, and then we can go into this bank of windows here. There are several windows. I have seen a lot of inspectors do a lot of different things. You could use a camera mounted on a pole to get you access to all of these seals. I've seen people use drones. Remember, if you use a drone, to make sure you do have your FAA license for doing a commercial application. And I know that InterNACHI does offer a drone course, which can help you with that. But you want to make sure that you look at all these windows. Some of these windows you can actually see from the second floor, which is good for us. But if you can't, you want to think of alternate means of doing that window inspection. So I'm going to look at the glass here and make sure these seals are in good shape. And once I've done that, then I can kind of conclude this action wall. I want to make sure I hit all sides of the box of this. Over here is a sewer cleanout. One of the things we recommend is a great ancillary service to any of your inspections is to consider performing sewer scope inspections. And this would be an excellent spot for doing one of your sewer scope entry points. It's a nice revenue stream, but it's also a great client service so that they know what they have as far as their sewer discharge goes.